Welcome back to the Deep Dive. Today we're taking a deep, critical look at the very foundation of how we build the world, jumping right into the work of a figure often acknowledged as, well, the father of modern cognitive science and design thinking, Don Norman.
It's funny, you can't really discuss how we interact with apps or infrastructure or even just filling out a complex form without citing his foundational work.
Absolutely.
hmm
For decades, he's been basically synonymous with the concept of usability.
Right, and that's driven largely by his masterpiece, The Design of Everyday Things. That book, it taught an entire generation why poor design is usually the culprit when we struggle with something as simple as a confusing door or a poorly labeled button.
It totally shifted the blame from the user to the system.
Exactly.
And we are definitely acknowledging that incredible legacy today. But we're going to pivot pretty quickly to his most urgent and, frankly, his most demanding work. Norman has entered what he calls his fifth retirement.
His fifth, yeah. He is far from slowing down, though.
Far from it. His focus is no longer just, optimizing the refrigerator door handle or streamlining an app's user flow.
His mission has radically shifted. It's not about optimizing individual products anymore. It's about optimizing global survival. He's moving beyond that narrow focus of ease of use to tackling these immense, complex socio-technical issues.
The big ones.
The biggest. We're talking about the interconnected web of climate change, failing healthcare systems, global economic disparity, and he's demanding that designers step up and actually try to solve them.
And that's the core of our deep dive today. We're analyzing his powerful critique of contemporary design, a critique that argues the very models we use today are often unintentionally destructive to the planet and society.
We're going to trace the evolution of his thought from, coining the term UX all the way to advocating for this new framework he calls humanity-centered design.
And we're going to try to constantly connect these big ideas, the structure of global economics, the failures of international aid, back to the systems you encounter every single day.
Why does your new phone feel like it's impossible to repair?
Right. Or why are hospitals so prone to these life-threatening errors?
What does the design of a simple paper coffee cup tell us about global waste? That's the mission today, understanding this shift and really what it means for how the world must be rebuilt.
So let's unpack this evolution. Where do we even start?
Well, I think we have to start with the mess. If you've spent any time working in tech or engineering or even, administrative roles, you've probably drowned in the sea of confusing acronyms.
Oh, absolutely. UCD, HCD, human factors, cognitive ergonomics.
Interaction design, CX, UX. It seems like every new decade brings a slightly refined, slightly different label for what is essentially the same pursuit.
It's definitely a historical mess, and Norman doesn't shy away from pointing this out, does he?
Not at all. He explains that these terms don't come from some single coherent intellectual movement. They just sort of emerged from these parallel societies.
You had the traditional industrial designers over here.
Right. And the computer scientists over there trying to make software more intuitive. Then you had psychologists studying human perception and the human factors experts who were focused on safety in cockpits and power plants.
And they all kind of claimed ownership over these overlapping concepts.
Exactly. And so his advice to us today,
Just ignore it.
just ignore the labels. He really urges us not to get bogged down in the turf wars of terminology. What truly matters is the goal.
Which is, are we building systems that genuinely meet the complex needs of the human beings who are trying to use them?
That's it. The focus should be on functionality, utility, safety, not on what specific methodology we decide to call it this week.
The historical ambiguity here is particularly ironic, though, because Norman himself helped set the foundation for all this complexity.
He did. His early, incredibly influential work, published around 1986, was a book called User-Centered System Design.
And there's a little inside joke there, right?
Yeah, a little nod to his employer at the time. The initials of the book UCSD were also the initials of his institution, the University of California, San Diego. But that concept, user-centered system design, it became the North Star for an entire generation of engineers. But as we see today, attempts to rigidly separate that early term from later ones are often, well, just not productive.
It's almost comical how the terminology has metastasized since then. You'll read a textbook or an article about human-centered design, and the very first warning is often, do not confuse this with user-centered design.
Exactly. And Norman coming from the very genesis of these ideas, he just cuts through that confusion so bluntly. He just says, those are the same.
Right.
He sees this modern insistence on subtle differentiation as just perpetuating the historical mess rather than, advancing the real work of design. We need to look past the vocabulary and focus on the principles.
Okay, so let's talk about the single most dominant term in the digital landscape today, a term Norman also coined, user experience or UX. This story starts with one of his legendary retirements.
It does. It was 1993, and Norman left academia for the corporate world, taking on a role as a vice president at Apple. He was already a giant in the field, of course, but what he observed at Apple, a company that was supposedly obsessed with usability, was a fragmentation of the user's journey.
So what was he seeing specifically? What was the problem that led him to invent an entirely new term?
He realized that while the hardware, the physical computer or the mouse might be beautifully designed, the overall experience of buying it, setting it up, learning the software, and then dealing with tech support felt disconnected.
It's fragmented.
Completely fragmented and inconsistent. The quality of the total experience was actually decreasing because no one person or group was responsible for the entire journey. Design was totally siloed.
So he needed a term, and more than that, an organizational structure that forced people to think holistically.
Precisely. To unify these disparate efforts, he established the User Experience Architect's Office, and he proudly gave himself the title User Experience Architect of Apple.
He had to invent the title.
He had to invent it just to encapsulate the scope of the problem he was trying to solve.
And the term obviously stuck, but I think we can agree its meaning has narrowed drastically. Today, when most people hear UX, they immediately think wireframes, prototypes, maybe the layout of an app interface.
And that is such a gross underestimation of his original intent. When Norman conceived of UX, it meant the entirety of the experience. It's sometimes frustrating to see it reduced to just interface design.
So give us the full picture, using your example from the outline. What's the UX of engaging with this deep dive in Norman's original context?
Okay, so it encompasses everything. How did you first hear about this topic? Maybe a friend mentioned it, or maybe an algorithm on your streaming service suggested it. That's part of the experience.
Okay.
How did you decide to sign up or tune in? That involves marketing, perception, trust in our brand. Then, how did you remember to attend on time or fit it into your schedule? That's calendar integrations, notification design.
The whole lead up.
The whole lead up. Then, what are you seeing, hearing, and learning right now? And critically, the final component is, what will you tell other people about it afterwards? The experience is this sprawling, holistic system that begins long before you hit play and continues long after you're done. It is the entire user journey.
So if the original definition of UX meant the entire system, then we can see how his current concept, this humanity-centered design, or HCD plus ACRE, is less of a radical break and more of a logical, almost ethical expansion of that original idea.
That's the key connection right there. User-centered design, UCD, or even the early interpretation of human-centered design, HCD. It focuses intensely on the individual user and their immediate, bounded interaction with a product.
You're optimizing their efficiency, their pleasure, their safety within that product's little world.
Exactly. HCD Plus takes those same principles and expands the boundaries of the system far beyond the product itself to include global, long-term impacts on society and the planet.
So we're no longer designing just for a single user, but for, I guess, the entire human family and the resources that sustain us all.
It's the difference between designing a really fast, comfortable car, which would be a UCD success,
Right.
and designing a transportation system that doesn't poison the air or necessitate paving over miles of green space. That would be an HCD plus success.
It's basically an ethical overlay applied to the systemic principles he's been advocating for his entire career.
Precisely.
So let's pivot from the theory to the failures that make this shift to HCD plus so urgent. When a system fails, whether it's a simple household object or a complicated piece of software, our knee-jerk response, it's almost Pavlovian, is self-blame. We internalize the error. We think, I'm so stupid, or I should have read the manual.
And this tendency for self-blame is a massive, massive problem. It allows systemic failure to hide behind what looks like individual human error. Norman points out that the fault rarely, if ever, lies with the person trying to operate the system.
The fault lies entirely with poor design, a design that's just incompatible with basic human cognition.
And because we're conditioned to absorb the cost of that failure, it completely absolves the designer and the company that made it.
And this starts right in our kitchens with the classic human factors issue, the stove. This problem has persisted since, the 1930s or 40s? And every single day, Millions of people encounter it.
Oh, absolutely. Think about the typical kitchen range. You have 4 burners arranged in a square or a rectangle.
Right, 2 in the front, 2 in the back.
But then often the controls, the knobs, are just arranged in a straight line, maybe 6 knobs in a row if you include the oven. There is no intuitive natural mapping between that linear control layout and the spatial layout of the burner.
I will confess I have definitely made this error. You intend to turn on the back left burner to boil water, and suddenly the front right burner starts sizzling whatever you left on it.
It happens constantly, and while the user might experience, brief confusion or frustration or occasionally cause a minor accident, they rarely step back and blame the manufacturer for the terrible interface design.
No, you just think, I wasn't paying attention.
I wasn't paying attention. The design violates a core principle of human factors called mapping, the relationship between the control and what it controls. And because the manufacturer saved, a few cents by arranging the knobs in a straight, simple line, they've introduced cognitive complexity and potential danger into every single kitchen that uses that model.
That failure is annoying in the kitchen, but the problem becomes catastrophic when we move to critical environments, and particularly the healthcare system. Here, incompatibility isn't just an error, it's a design error that kills.
That's the crucial distinction. Often the individual pieces of equipment in a hospital are technically well designed. Brand A's infusion pump is fine on its own. Brand B's monitor is fine on its own. But when you put them side by side in a large ward, that incompatibility transforms the entire ecosystem into a failure state.
So what does that actually look like in practice for a nurse on a shift?
Imagine a nurse on a busy night shift rushing between patients. They might have a continuous glucose monitor from one company, a ventilator from another, and an IV infusion pump from a third.
All for one patient.
All for one patient. Each system uses a different visual language, requires a different sequence of button presses to start or stop, and has auditory alarms that sound different but might signal the same critical status.
So the nurse has to shift cognitive gears constantly between these incompatible systems.
Constantly. It increases the cognitive load exponentially and basically guarantees that they will eventually make a mistake. And in that environment, a mistake can be fatal.
The analogy you used in the outline is so powerful. It's like trying to drive in a world where every single car manufacturer decided to put the gas pedal, the brake, and the steering wheel in fundamentally different locations.
Precisely. We take for granted the fundamental standardization of automobile controls. That standardization is a massive, life-saving design achievement that we don't even think about. But in specialized medical equipment or complex industrial settings, that standardization is just absent.
And that absence is a design failure, even if every individual component on its own seems okay.
It is the design failure.
So what's standing in the way of this standardization? I mean, it sounds like an obvious public safety imperative.
The barrier is purely business and financial self-interest. Market leaders actively hate standardization.
Why is that?
Well, if you are the leading manufacturer of ventilators, you want your interface to be unique, beautiful, and look superior to the competition. You want hospitals and medical centers to be locked into your ecosystem because your products don't easily mesh with others. Standardization erodes that market advantage.
So it's the smaller, non-leading companies, the ones struggling to compete, who are usually pushing for standardization because they're hoping to create a more open playing field.
Exactly. The tension is crystal clear. Profit motive versus fundamental safety design.
This business safety conflict is just so vividly illustrated in Norman's famous anecdote about the ignored safety protocols in high-voltage environments. And this isn't about a careless novice. This is about a systemic failure that trapped a seasoned professional.
It really is. Let's walk through that story.
Okay, so set the scene for us.
We're talking about an experienced senior worker in an electrical substation. His task for the day was mundane. Find and read the serial number on a newly installed transformer.
Simple enough.
But it was dark, the lighting was poor, and the serial number plate was in a really awkward spot, difficult to access and even harder to read. And because he's an experienced worker, he carries this internal pressure to get the job done efficiently and correctly. He sees setbacks as a personal failure.
And he knew the rules, right?
Yeah.
He knew the safety protocol.
Oh, he absolutely did. There were signs posted everywhere mandating that he stay back at least 1 meter from the high-voltage lead, the dangerous live wires. He tried to read the number from a safe distance, but he couldn't.
So he gets frustrated.
He gets frustrated. He decides to use his phone camera's flash, thinking a quick snapshot will solve the problem. But as he's positioning the camera, he's crouching down, he's maneuvering to get the perfect shot in the dark. He inadvertently moves too close to the lead.
And the high voltage arcs.
It jumps the gap. The next thing he knew, he woke up in a hospital bed, having suffered a severe electrical accident.
And his immediate reaction again was that internalized blame.
Immediately, he blamed himself. He said, "I knew the rule. I was stupid. I should have paid attention." But when Norman analyzed the incident, he showed that the failure was inevitable. The design of the situation forced the human worker to operate at the very boundary of human limitation. Poor visibility, high mental load, a tricky physical maneuver. The system set him up to fail.
So what was the simple design solution that management missed?
It was incredibly simple and inexpensive. A small, temporary cardboard shield.
A piece of cardboard.
A piece of cardboard. This shield could be installed before the work started, physically preventing the worker from moving within that 1-meter danger zone. It changed the system from relying on human memory, vigilance, and willpower, which we know inevitably fail under pressure, to relying on a physical constraint that made the error impossible.
The shield design addressed the environment, the human's goal, getting the serial number, and the human tendency to get a little too close all at once.
And crucially, Norman noted that this specific solution and other similar expert reports emphasizing redesign and physical constraints had been proposed before, but they were continually ignored by upper management.
Why? Why would they ignore something so simple?
Because management was primarily interested in problem identification after the fact. They were focused on compliance, on audits. They weren't interested in redesigning the fundamental safety protocols or the physical environment before purchase. The focus was on paperwork, not preventative design.
This points to a huge structural flaw, not just in companies, but maybe in the entire human factors profession. The very people who are supposed to be advocating for safety and usability.
Yes. Norman's critique is that human factors and similar professionals often get trapped in this academic cycle. They spend too much time identifying problems, generating reports, and attending specialized conferences where they end up just talking to ourselves.
Complaining to fellow experts about the issues they face in places like hospitals or industrial sites.
Exactly. They're excellent at analysis, but they lack influence over the actual implementation, the redesign, or, most critically, the purchasing decisions.
They're providing these elegant technical solutions when that they really need to be providing is a business strategy.
Exactly. They have to step out of their academic or specialist silo and address the executives, the people who sign the multi-million-dollar contracts for equipment. And they have to frame the redesign not as a humanitarian appeal, but as a quantifiable solution to business risks. Reduced accidents, lower liability insurance, increased efficiency, and reduced downtime. They have to transition from being a problem finder to being an executive-level business strategist.
These deep-seated systemic failures, where the business model actively compromises safety and the profit motive prevents standardization, this is really what crystallized Norman's shift to humanity-centered design. He made this profound ethical choice to just stop writing about consumer goods.
His reasoning was so clear and compelling. He stated he could no longer, in good conscience, continue to destroy the environment in our world by focusing on optimizing the next generation of disposable consumer gadgets.
He felt his expertise was being used to optimize a system that was designed for consumption and waste.
So he pivoted his entire focus to these massive, intractable, global issues. Hunger, education, public health infrastructure.
And the root economic flaw he identifies, which touches every single one of us, is the current business model that is built on planned obsolescence.
It is the engine of consumption, and it's surprisingly old. Planned obsolescence didn't start with the iPhone. It actually originated in the automobile industry, primarily in the United States, way back in the 1920s and 30s.
Cars were originally built to last for decades.
Which was terrible for the balance sheets of the manufacturers. So the model was deliberately shifted to prioritize cosmetic changes and minor mechanical failures that would force customers to buy a new car every few years.
And today, that accelerated model is applied ruthlessly, especially to electronics. They are designed not just to be replaced, but to actively resist any kind of repair.
They are, as he describes them, nailed together. Parts are glued in, complex components are soldered together using specialized equipment that the average person or repair shop just doesn't own.
The batteries are a huge one.
Oh, the batteries are often glued into casings, making a simple replacement prohibitively difficult or costly. This intentional design complexity makes separating the materials for recycling nearly impossible.
And even if the hardware were physically robust enough to last, the software steps in to force obsolescence anyway.
Absolutely. Your modern device constantly requires updated operating systems, which often demand chipsets and processing power that older models are intentionally unable to handle.
So the manufacturer gets to say, oh, your phone is perfectly fine physically, but it just can't run the new program or the essential security update.
Which forces the purchase of a new, functionally almost identical piece of hardware. It is a design cycle of disposability.
And this constant design cycle of replacement leads directly to environmental devastation, which Norman meticulously breaks down into 4 sequential stages that touch every single product, from a smartphone to a t-shirt.
The first stage is mining. We destroy the land, often through environmentally taxing practices, just to extract the exotic materials, the rare earth minerals, the complex metals required for these devices.
Then stage 2 is manufacturing.
Right. Factories generate vast amounts of pollution, spitting out fumes and chemicals into the air and waterways during the assembly process.
Stage 3 is the shipping stage, the massive logistical cost.
Products, components, subassemblies. They're flown and shipped across the globe multiple times before they ever reach you, the consumer, adding astronomical carbon costs to every single item.
And finally, stage 4 is disposal.
Where we're left with mountains of non-recyclable electronic junk, discarded plastics, textiles saturated with poisonous dyes, and general waste that our current infrastructure simply cannot handle. The system is designed for a linear flow. Extract, make, dispose. That's it.
It's a real tragedy that the very same design principles that lead to objects we find aesthetically beautiful, the thin profile, the seamless glass, the polished finish, are the same principles that guarantee environmental destruction.
Because they prioritize visual beauty and streamlined assembly over repairability and resource recovery.
You see this tragedy even in seemingly innocuous objects, like the ubiquitous paper coffee cup. Most people feel good throwing it in the recycling bin because, well, it's paper, right?
But the design of that cup is inherently deceitful.
How so?
In order to contain the hot liquid and maintain its structural integrity, the cup requires a very thin plastic or polyethylene lining that's laminated inside the paper. And that plastic lining cannot be easily separated from the paper fiber using standard high-volume municipal recycling processes. So it often just contaminates the paper stream, forcing the entire cup to be sent straight to a landfill.
So a simple daily object that's designed with convenience in mind becomes an emblem of systemic waste because of a difficult-to-separate material composite. So if the business model of selling products is fundamentally flawed because it's built upon waste and a linear economy, what is the humanity-centered solution? How do we actually break this cycle?
Well, the primary goal has to be a circular economy, one that mimics natural systems where the waste from one process becomes the resource for the next.
Like a banana peel composting to fertilize the next banana plant.
That's the ideal. Products must be designed for reuse, for repair, for disassembly, and built to last as long as possible.
And the proposed business models shift to support this. This is the big one. Moving from selling products to selling services.
This is the critical financial lever. If a company makes money only when you buy the next version of its product, it is financially incentivized to make the current one fail. But if the company sells a service, the continuous performance of the product, its financial incentive is completely reversed.
Okay, so how does that look practically?
Let's think about lighting. Instead of selling you a light bulb, a company sells you illumination, a service contract guaranteeing a certain level of light output in your office for, say, 5 years. They own the fixture and the bulb.
So now they are incentivized to use the most durable, energy-efficient, and long-lasting components possible.
Because every single time they have to send a technician out to replace a burnt-out bulb, it costs them money. It eats into their profit.
That makes perfect sense. The same logic would apply to high-cost machinery, I imagine.
Exactly. Norman uses the example of an engine manufacturer or a company that makes pillboxing machines for pharmaceuticals. Instead of selling a $10 million machine outright, they sell the service of producing 1 million boxes a year.
So the manufacturer retains ownership.
They retain ownership, which means they are now fiercely incentivized to maintain the machine, make it efficient, remotely monitor its performance, and ensure it lasts 20 years, not 5. This shift forces HCD plus principles, longevity, efficiency, repairability, to become the financially rational decision for the company.
And that is where true leadership emerges. Not just creating sustainable systems, but creating systems where sustainability is actually the most profitable path.
The shift to humanity-centered design means we have to grapple with problems that are not just technically difficult, but politically, economically, and socially complex. These are what designers call wicked problems.
They rarely yield to simple, elegant solutions.
Not at all. And climate change is the ultimate example. We have the scientific consensus, we have the technological roadmaps, yet we have this crippling political inertia. Norman brings up the United Nations Committee of the Parties, the COP meeting.
The COP has met 28 times. That's nearly 3 decades of high-level global negotiation.
And yet, despite all the data and all the warnings, Norman argues very little, almost nothing of substance has been achieved in terms of global unified action. This isn't a failure of engineering or chemistry. It's a failure of human and political systems.
Part of this failure, he argues, stems from the metrics we use to define the problem and measure progress. They're often just divorced from reality or human understanding.
The critique of gross domestic product, or GDP, is central here. Economists and policymakers treat it as the ultimate indicator of success, yet Norman calls it a meaningless number for most people.
It's a bizarre metric when you dig into it.
Think about what GDP actually counts. If a factory pollutes a river, that manufacturing output increases GDP. Then, when money is spent to clean up the polluted river, that cleanup activity also increases GDP.
So the pollution and the remediation are counted twice as economic growth. The number is totally detached from human well-being, ecological health, or sustainability.
And this flawed metric completely blinds us to true progress. The same problem happens when scientists try to communicate urgency using their own standardized metrics, like temperature rise. Scientists warn that we must limit global warming to 1.5 or 2 degrees Celsius above pre-industrial levels.
But the average person experiences more temperature fluctuation than that every single day, right?
Exactly. When the temperature drops 5 degrees overnight, no one panics. The public doesn't grasp that scientists are talking about a tremendously destructive increase in the average thermal energy captured across the entire world over time, not just the daily forecast.
So the failure lies in the design of the communication itself. It lacks the necessary context for the average person to act or even understand the severity of the problem.
We need new ways of measuring health and progress that are intuitive, holistic, and meaningful.
And what alternatives does Norman point to?
He advocates for more comprehensive, systemic measurements like the donut model that was developed at Oxford by the economist Kate Raworth.
Instead of relying on a single, misleading number like GDP.
The model uses a visual dashboard of multiple variables. A dashboard makes perfect sense to designers. It moves from one abstract metric to many tangible, interconnected indicators.
Can you describe the donut for us?
Sure. The model frames human well-being as needing to exist within an ecological ceiling, that's the outer ring of the donut, defined by planetary boundaries like climate change and biodiversity loss, and a social foundation, that's the inner ring, defined by fundamental human rights like water access, housing, and education.
So the goal is for all of society to fit sustainably within the donut, between that ecological ceiling and the social foundation.
Precisely. It allows for specificity. You could look at a country and say, you are performing great on the social foundation, your healthcare is superb, but you are blowing past the ecological ceiling with your CO2 emissions.
It allows decision makers and the public to focus on specific strengths and weaknesses in a transparent way, rather than being misled by a high GDP figure that masks deep-seated social or environmental decay.
And this holistic, contextual approach must extend to global aid, where Norman highlights the damaging effects of what he calls the tyranny of experts.
The idea that well-meaning, centralized expertise, whether from governments or massive foundations, often fails, and fails spectacularly.
These organizations spend billions on aid, but the solutions are often too generalized, too abstract, and dangerously top-down. The experts design solutions in sterile, advanced labs in the West, but those solutions completely ignore the local context, the local materials, and the local knowledge on the ground where they're implemented.
Give us the classic anecdote, the water pump.
It's a perfect illustration of what he calls colonialist design. Advanced, high-tech water pumps are donated to communities in developing nations. The pumps work beautifully for a while,
Right.
but because they're built using specialized, proprietary, imported components, when they inevitably break, which all complex machines do, they cannot be fixed locally. The community is left with an expensive, broken machine, and the experts who installed it are long gone.
So what did the community actually need?
They needed a design that factored in their existing infrastructure and skills. The local people know how to tinker with bicycles. They have access to bicycle parts, they understand how to repair them, and they have the tools.
So a water pump solution that was co-designed with the local community, using readily available materials like bicycle chains and components.
It might be less technologically advanced, but it would be durable, maintainable, and ultimately sustainable.
This shifts the designer's role from being the benevolent provider of solutions to being a facilitator. The approach has to be anti-colonialist. The solutions must come from the people through what he calls co-design.
It's a recognition that the people experiencing the problem are the most profound experts in their own context. And this approach isn't just theoretical, it's happening today, driven by citizen initiative, even in highly regulated fields like medicine.
The example of the artificial pancreas is incredibly powerful.
Absolutely. Diabetics who rely on insulin pumps and continuous glucose monitors, or CGMs, realized they couldn't wait 10 or 15 years for pharmaceutical companies and regulatory bodies to commercialize a fully integrated artificial pancreas.
The technology existed, but the bureaucracy was crippling.
So they decided to take matters into their own hands. A community of tech-savvy patients and parents reverse-engineered their CGMs and pumps. They developed their own software, they published the code on the internet. It's an open-source movement called #We'reNotWaiting, and they created their own integrated systems to manage blood sugar and automate insulin delivery.
They designed for themselves.
They designed for themselves, incorporating feedback loops and safety checks that the industry was too slow or too risk-averse to implement.
And what's the result of this grassroots, citizen-driven design?
Today, hundreds of people are living healthier, more stable lives using these unsanctioned, community-built systems. This demonstrates that when centralized regulation or corporate inertia fails, local knowledge, fierce motivation, and bottom-up collaboration can achieve profound systemic breakthroughs, bypassing the traditional design hierarchies entirely.
Okay, so the problems are massive, complex systems. The political resistance is immense. Grand, decade-long plans often fail. So what is the practical implementation strategy for HCD plus vendors? We can't just throw out the global system overnight.
The strategy is what Norman calls the muddling through approach. It acknowledges the sheer complexity of reality. A massive, high-cost, 10-year systemic overhaul attracts ferocious objection from every vested interest, and it invariably collapses when unforeseen changes happen in year 3 or 4.
So instead of a grand blueprint, we take small, iterative steps.
Exactly. You define the ultimate goal, the desired future state, but you achieve it through very small, incremental steps. Small steps face less political objection, they require minimal funding, and if they fail, nobody really notices. You just pivot and try the next small step.
And if they succeed?
If they succeed, they facilitate the next step, building momentum and proving viability.
That makes the whole system more resilient. You don't have all your resources locked into a single, fragile solution.
And it allows for flexibility. As requirements inevitably change over time because technology advances or social needs shift, you can easily modify the ultimate goal without having to scrap a colossal, multi-year, multi-billion-dollar investment. Muddling through is the practical path for achieving systemic, humanity-centered change in a politically complex world.
The success of this massive shift from UCD to HCD plus really requires a fundamental redefinition of the designer's role within organizations. Currently, as Norman sees it, designers have a power problem.
They absolutely do. They are often brought in late in the process, relegated to making the product pretty or polishing the interface after all the major strategic, technical, and business decisions have already been made.
Decisions about what to build, how to build it, and for whom. Those have already been fixed by executive teams.
Right. They're operating in the middle tier, executing craft skills, but not driving the direction of the company.
But if they are going to drive systemic, humanity-centered change, they have to move up, right? To the CEO, the CTO, the chief product officer level.
They must. And to ascend to leadership, they have to become generalists. They must become business persons, to use Norman's term. They have to be willing to step back from the narrow zealotry of just design principles and acquire a vastly broad background. History, philosophy, economics, business management.
They need to understand the constraints and the incentives that are facing the executives and the complex political landscape the company is operating in.
It means they can't rely on just showing off design awards or beautiful interfaces to make their case.
No. They have to present their solutions framed entirely in terms of business impact.
They need to quantify the value of their HCD Plus solutions in terms of reduced operational costs, increased revenue streams, maybe through that service model we talked about, mitigated reputational risks, or improved long-term customer loyalty. He found that the most valuable people on his teams at Apple were those who could recognize when a human factors problem while real, was less critical to the company's survival that week than, say, a manufacturing or a financial issue.
This need for a broader skill set is becoming even more urgent now with the acceleration of artificial intelligence. How does AI change the design landscape?
Well, Norman, who was instrumental in the early days of deep learning through his lab's work with figures like Geoffrey Hinton, he views AI as a fundamentally powerful tool, but one with inherent limitations.
Okay.
AI is, at its core, a sophisticated pattern matcher with no morals, no ethics, no nothing. The recent breakthrough wasn't a theoretical shift. It was the fact that today's computers are exponentially more powerful, a million times faster than the neural networks they were experimenting with decades ago.
So AI excels at tedious mechanical tasks that rely on pattern recognition.
Precisely. AI will quickly take over the mechanical drudgery of the design process. Reading and diagnosing radiological images, solving highly complex mathematical equations, generating boilerplate code, or executing mechanical graphic design tasks like logo generation based on a massive data set of existing styles.
So this isn't a threat to the human designer then. It's a massive opportunity to elevate their role.
It is the ultimate opportunity. It frees human designers from the repetitive mechanical work and forces them to focus on the truly human elements. Creativity, defining and framing the problem correctly, setting the real ethical goals, and questioning the fundamental constraints of the system.
That sounds a lot like the shift that happened in art when photography was invented.
It is a perfect analogy. When the camera became capable of capturing a perfect, realistic portrait or landscape, artists didn't vanish, they pivoted. They were freed from the burden of hyperrealism and began exploring expression, emotion, and multi-perspective reality.
Which led to movements like Cubism, what Picasso did.
Exactly. AI pushes designers to a higher, more philosophical and systemically reflective level of practice. It forces them to ask not how to build the perfect product, but why we are building this product in the first place.
This all necessitates a complete redesign of our education system to support this new, generalist, reflective designer.
Norman argues that education must stop relying on rote memorization because information is always available at our fingertips. Furthermore, we have to stop teaching disciplines like the STEM fields in isolation. When a student learns calculus without understanding how it relates to social dynamics or chemical engineering, they lose motivation and context.
So he advocates for what sounds like a continuous problem-based education.
Exactly. Education should be structured around solving complex, real-world problems that force students to work in integrated, diverse teams and synthesize multiple fields simultaneously. You need math, chemistry, social science, and engineering all working together to tackle an issue like urban sprawl or sustainable food production. The ideal team isn't just diverse in opinion, but diverse in fundamental skills and background.
Finally, before we wrap up, we have to return to a persistent theme in Norman's work, and one that is often aimed at Apple, where he spends so much time: the pursuit of simplicity.
Yes. The modern obsession with simplicity, particularly the aesthetic simplicity of interfaces, has, in his view, actually damaged usability. The modern iPhone, for instance, removes words and clear labels because words are ugly and they clutter the screen.
Which means the system now relies on users memorizing a complex vocabulary of physical gestures.
Right. You have to memorize that a two-finger tap does this, a swipe up and hold does that, a tap and hold does something else entirely. This turns the interface into something mysterious, requiring intensive cognitive training before it becomes usable.
So while Joni Ive is a brilliant industrial designer capable of creating these stunning objects,
the unwavering priority on appearance too often sacrificed fundamental clarity and usability.
that focus on appearance blinds designers to what real simplicity even means.
Because the true complexity of simplicity, he argues, is not making systems easy to use when everything is working perfectly. Anyone can design a beautiful, simple flow when the user is doing exactly what the designer expects.
So what then is the hardest part?
The hardest, most critical part of design is making systems easy to use when something inevitably goes wrong. When the system breaks, when a user makes an error, when the network disconnects, the user needs immediate, understandable feedback. What happened, why, and what is the single, clear action they must take to recover? Designers who only focus on the perfect sunny day flow have missed the critical moment when usability truly, truly matters. Hashtag outro.
So we've taken the deepest dive into Don Norman's ambitious pivot, tracing the design evolution from optimizing the individual user experience all the way to focusing on systemic, global, humanity-centered design. We learned that blaming the user for operational failures is a systemic crime, whether it happens with an incompatible stove or in a life-threatening hospital ward.
And we recognize that massive global problems, from climate change inertia to the tyranny of top-down aid, require us to abandon the dream of the revolutionary blueprint in favor of the flexible, resilient strategy of muddling through, taking incremental steps toward a complex, evolving goal.
And most importantly, I think, we've outlined the path forward for the modern designer. They have to stop being just craft specialists, concerned only with aesthetics, and elevate themselves to be executive-level generalists and business strategists, translating their solutions into quantifiable value for the organization and for the planet.
The final provocative thought we have to leave you with stresses the biggest conflict inherent in all of this. The goal of creating meaningful, sustainable systems often conflicts directly with the heavy pressure of short-term capitalism and the pursuit of exponential quarterly profits.
Norman's work ultimately asks you to consider how your own organization can transform its structure or its business model, moving from selling ephemeral products to selling durable, profitable services, to ensure that good design that benefits both humanity and the planet, becomes the only financially viable option.
This need for banding groups together, designers, engineers, executives, customers, and governments, to solve these truly complex global problems is, after all, the entire purpose behind the UN's 17th Sustainable Development Goal. Partnership for the goals. What specific changes must you advocate for today to align profit with progress in your environment? That right there is where true design leadership resides.